Hi everyone, welcome to this, our latest Ask the Expert interview. And today I'm joined by Thomas Glenday from manufacturer Bulgin, who create and manufacture a whole series of connectors, especially and particularly those for use in harsh environments. And so we're going to talk a little bit about the harsh environments themselves, an understanding of what that means, and then a little bit about the things that you need to be aware of when selecting connectors for that kind of environment. So Thomas, welcome. Glad to have you with us.
Hi there. Glad to be here, Dave. Let's get on with chatting about connectors and environments.
Fantastic. So I suppose the first question is, we need to talk about harsh environments. What are we actually talking about when we mention harsh environments?
So I think really it's a broad subject, and what classifies as a harsh environment for the user case of any piece of equipment can vary dramatically. Obviously, industrial settings are more generally considered harsh over that of maybe your more domestic setting for a piece of equipment. But really, it's where that piece of kit is going to have to deal with some form of environmental situation that may require it to withstand situations and conditions that are not sort of normal in your everyday setting. So that might be something that's exposed to the outdoor environment continuously, where we'll see fluctuations of weather conditions, or it might be something in a factory floor setting where different materials can be airborne. There can be, lots of different considerations. Light levels can even be a determining factor of how you might select going about using a particular connector over another.
Okay, and so we're talking specifically about using electronics in these kind of conditions, because of course electricity and electronics don't tend to like becoming wet or being exposed to harsh temperatures. So this is the environment we're talking about. It might also be worth mentioning the difference between a harsh environment and a hazardous environment, because that is relevant to Bulgin products. When we talk about hazardous environments, what are we talking about there?
So the difference there really is where you're exposing this piece of equipment. Ultimately, connectors normally form part of a bigger device, and hazardous environments where there's a risk to the well-being of either an operator or even facilities. So if we're in a harsh environment, we're generally withstanding something that's not going to necessarily cause harm. But when we move into hazardous environments, it becomes much more critical that we're ensuring we're meeting the requirements of that environment so as to not cause harm. Now that, like I've mentioned, that may be harm to the user or harm to the wider environment. As a business, we want to ensure that our assets are protected. So our assets are our people. That is by far the key consideration here. But it is also our buildings and our pieces of equipment. So how do we ensure that a potential hazardous environment, whatever we're introducing to that environment, is able to handle those sort of potential dangers and risks? And that could be an environment where there's potential flammable hydrocarbons that may escape into the air. A very classic example of that would be in sort of oil and gas exploration, for example. But actually, it's a lot more than that, and it's a lot wider ranging. Even particulate in the air, factories that might be using powdered materials. A powdered material airborne becomes a potential explosive environment. And it's something that people don't always consider, that a simple product in itself that may seem harmless in certain conditions absolutely becomes hazardous. And that is really a key consideration for anybody who's introducing, certainly power being probably the main concern with electronics. How are we ensuring that connection of power is not creating a condition that's going to lead to that that potential hazard becoming a realised danger and risk to health or property.
Okay, so we've talked a little bit about harsh environments. We've talked a little bit about hazardous environments because they are subtly different. So I suppose the next question, in broad terms, is how do we design for these environments?
So there's lots of considerations that come in there, even down to sort of, you've got real basic considerations first and foremost, and that will be material selection. That will be the physical strength of a component in such an environment. We need to make sure that it's not only designed to deal with the environment, but it can withstand any potential risks to it in itself. So if there's an impact risk, that the design is robust enough and has an element of safety to it that can withstand unexpected occurrences, as well as that of its normal operating condition. Beyond that, we need to try and design things that are intrinsically safe. So they, how can we look at how we go about constructing a component? We're talking broadly around connectors at the moment, as obviously it's Bulgin's key area of our business, but ultimately it's that intrinsic safety built into a device that I think is really critical at the design phase.
So the key thing is that we're going to be understanding the environment itself. And so let's talk a little bit about IP ratings, because that's critical to Bulgin products. It's critical to almost every component that's going to be used in these environments. So let's just touch briefly. What is an IP rating and what does it mean?
So first and foremost, just for the audience, I'm sure most people are well aware that the IP ratings in what we're talking about here, IP can stand for various things, but we're talking specifically around ingress protection. And ingress protection is stopping foreign bodies, foreign materials from entering into the device that we're trying to protect. So when it comes to a connector, that's ingress into the internals of that connector body or ingress into the enclosure of which that connector is a part of the bigger machine or device. And IP ratings are split into dealing with solids and dealing with liquids. And that's where you have this two-figure rating. And broadly speaking, we're, as a business dealing with harsh environments, we're sort of right at the top end of those ratings. But it's breaking down how a solid may be able to enter or ingress into a object. And those solids start right the way down as something like a physical hand. So can I put my hand into the backside of a microwave and shock myself? And then it steps down into smaller and smaller objects, in essence, until we get into the high levels of ingress protection, where we're talking about constant exposure to dust and particles that are of a small size. In a similar way, the second part of the rating, or the second figure in the rating, deals with liquids, and that's a continued severity of the exposure and therefore the protection that's needed to deal with it. So we're starting from a low-down rating dealing with occasional splashing of water, perhaps light exposure to external weather conditions. So it might be something that's placed outside, but actually it's in a semi-sheltered position. So it only needs to deal with light exposure to water that's kind of falling over the object, for example. And as we step down into those, or step through into the higher levels of protection, we're talking about continuous exposure to water jets. The severity of those water jets becomes important. How those jets of water may or may not interact with the device. So is it from a straightforward angle, or is it coming from a side projection? And then again, we're looking at the higher levels where we're dealing with continual submersion at pressure, so at depth, being sort of the higher end of where we are, and really the area that Bulgin primarily designs our components to deal with.
So when we're looking at these IP ratings and we're looking at the ones that we're going to be talking about today, what are those ratings that typically are used on Bulgin connectors?
So typically we design for IP68 environments. So that is exposure to dust and exposure to a continual submersion in a liquid. And I think it's important that we talk about liquids, not necessarily just water. It sort of leads on to how do we design for these harsh environments. There's a big difference submerging a product in clean water to a salt water or seawater, for example, being a very obviously common example of that, as it is to exposure to a chemical, alkalines or acid environments, or even detergents pose different risks to product to that of a kind of natural water environment.
And we've also got IP69K, which I believe is talking about dynamic water pressure. There's a subtle difference there as well, isn't there?
Yeah, absolutely. And you're sort of getting into more specialist areas of the ingress protection ratings at that point. And they go hand in hand with other exposure type testing that we conduct. So salt mist is a common other area that you need to consider, particularly in, for example, marine environment.
Okay, so we've talked a little bit about the environment. We've talked about a little bit about how we understand what's going on in that environment and how we can identify it. So let's talk a little bit now about the actual effects that these environments have on how a connector is designed. So you've touched upon, for example, salt mist sprays and the fact that we're going to have to use some materials over others. So what are the effects that designing for these environments have on the physical form of the connector and what it's made of?
So once we've established the environment that the product needs to operate in, and as you've alluded to, how do we actually deal with it? What are the key considerations that we have to take into account? So that can be, I mean, it's not just about ingress protection here. So we've talked a little bit about the robustness of a product and material selection being absolutely key. So there's pros and cons of many different materials that you can use in a connector body. Broadly speaking, plastics versus metallics is a really key consideration as to why a user might select a particular product. And the material has in itself many functions to perform. So it's the physical strength of a material and why you would select it for that reason. But physical strength in itself is a complex topic. So are we looking for something that can withstand potential impacts, and then ductility becomes important? Are we looking for something that is going to have prolonged exposure to sunlight, where UV is actually, or ultraviolet radiation is actually a harsh environment in itself? Materials degrade in sunlight. I think it's something that people are all familiar with, where, you have garden furniture and the fabrics fade over time. That's simply just by being exposed to that radiation in the outside environment. But beyond that, we need to consider the actual use of the product. Where is it going to be installed? How's it going to be managed? How's it going to be handled? Not only does the environment itself need to be withstood by that connector, but so does the therefore user case. So are individuals interacting with these pieces of equipment wearing personal protective equipment? Does that mean that visual aids need to be apparent? Do we need to design to ensure that connectors will only mate in their correct fashion? Because it is difficult to visually see the orientation that we need to connect that connector in. So you need to physically restrain it so that it can only be connected in the correct way. Is the user, I said about personal protective equipment, are they wearing gloves, and therefore the intricacy of their dexterity is reduced, and it needs to be sort of able to be handled in a robust way? Do we need visual aids that help with people knowing that the connector has been mated correctly? Of course, that becomes critical if the design has overcome all of those challenges, then the user case and the correct installation is absolutely critical, because it's not going to function correctly if it's not been used correctly. So there's a whole host of different considerations that are taken into account when we're trying to deal with these sort of environments.
And then we have to look at we talk about the use case. Connectors, after all, are simply devices that connect two electrical circuits together. So the electrical characteristics of what the connector is going to have to do, that's going to have an impact on things like size and configuration as well, isn't it?
Yeah, absolutely. So, whether we're talking about conducting power, and broadly speaking, the larger the power we're trying to deal with in terms of currents and voltages, the physical larger size the connector needs to become to be able to handle those currents without causing overheating, for example. And then that's simply talking about power, which is a major thing that we deal with. But then if you're talking about data and carrying signals, we need to start talking about how we can handle data rates. It's becoming more and more that data is being captured by devices in all sorts of settings. Again, even in our home environment. The Internet of Things is a major topic at the moment, and the industrial Internet of Things. And capturing all this data means that we need to then transmit it. We need to transmit it reliably, and we need to transmit it without interference. We need to handle those speeds of this vast quantity of data that we're gathering. So then we start to look at how a connector ensures that we maintain shielding throughout. So we can have a shielded cable, but how do we maintain that in creating a connection which ultimately is only put there in the first place to enable generally installation or servicing of some description. Connectors aren't ultimately implemented into a device or a cable for no reason. It's because we have to be able to make that disconnect. So it's absolutely critical that these considerations are part of it's part of a design spec of the connector, not just its environment, but its actual purpose.
So we've talked about the environment, we've talked about the effect that the environment's going to have on things like connector design, and we've talked about some of the specifics of the things that we've got to consider when we're talking about connector and we're selecting a connector for any particular application. So let's home in a little bit on the Bulgin product. So Bulgin is a connector company that's been around for a very long time, and the flagship product when we come talk about harsh environment connectivity is Buccaneer. So to give us a brief overview, a sort of the elevator pitch on Buccaneer, and then we can talk about it in a little bit more detail. What is the Buccaneer connector?
So as you said, sorry, David. Yeah. So as you said, the Buccaneer is our sort of flagship range, and over a number of years, Bulgin have been in the business of connectivity for we're fast approaching our century of being in the business. So the Buccaneer range started out some time ago, and I think what has always been a key for us is sort of a level of standardization across the product. So our Buccaneer range as a connector body is offered in lots and lots of different guises to deal with standard data interfaces, power, different bespoke uses. We offer a vast range of different pin counts and conductors to deal with different DC and AC currents, so on and so forth. It's a really broad range, and we've continued to develop it and continue to introduce new ranges that sort of complement that core initial product and the sort of core initial place we want to put ourselves in the market.
Bulgin, one of the things that Bulgin Buccaneer connectors is known for is that power connection in a tough environment. So we're talking about big beefy pins that can take large currents. Tell us a little bit about some of the safety features that are built into Buccaneer that make them ideal for that. I'm thinking about things like leading earth and what that actually means and how that works.
Yeah, I mean, in power, earthing circuits is an absolute primary safety concern. It means that there's a way in which that should things go wrong, that current can be safely carried to Earth. That's primarily what that functions for. And I think most people are very familiar, certainly in the UK or wider around the world, with domestic power plugs, how we plug in near enough everything in our home environment. And certainly the UK domestic 3-pin plug that we're so familiar with, everyone is aware that the top or individual earth pin is the longest. And what that results in is that when you go to plug any electrical appliance or device in the home, the first connection that's made is the earth. So the earth circuit is always connected primarily before anything else. It's also therefore disconnected last. And that's a really fundamental key safety consideration when working with power, and something that we've carried through into the Buccaneer range and all of our power connectors. Certainly when you're talking about making anything as a live connection, a leading earth is really a key first consideration for the user.
So we've talked about power with relation to the Buccaneer connector, but the Buccaneer connector has developed over the years, and you've mentioned data and signal. And we used to things like USBs and various other data interfaces. How does the Buccaneer cater for customers who need that kind of interface?
So we have always worked with a number of sort of industry standard connector interfaces. You've mentioned USB there. RJ45 is another sort of classic standard Ethernet type plug that we're all familiar with. And really what Bulgin are doing are taking these standard interfaces and embodying them in a device that protects them, or our connector in this case. I mentioned standardization earlier. It's always been key to me, and I think to a lot of people, that familiarization is really important, and people become used to operating with certain familiar devices. You could talk about mobile phones, and we won't start on the Android versus iPhone debate. But people like familiarity in what they're using, and the Buccaneer range does that. It allows you to have a familiar interface such as USB embodied into a connector that allows you to use that in an environment it wasn't initially designed to be used in. If we go out and just buy a standard USB interface, USB-C, USB Mini, it doesn't really matter which one we're talking about here. We can't put that into an environment that may be in a factory setting or in an external, just dealing with general weather conditions. So what we do is we take those protocols, we embody them into a protected device, and that allows our customers to use these standard protocols, to use these standard connectors, something that they're familiar with and they understand, and then embody them into a Buccaneer connector that we hope people are familiar and understand. And it kind of marries the two into a product that ultimately can be easily incorporated into a design of a system or a machine, and deal with the environment whilst providing that connectivity solution.
And it's also worth talking about that the Buccaneer range has a few even more specialist areas that it goes into, so that there are fibre options, and I believe there's an ATEX version that's designed specifically for the hazardous environments we've talked about as well.
Yeah, so fibre is something that is becoming more familiar with all the time. People are starting to see fibre applications over that of your sort of classic conductors. Fibre for us is all about carrying vast or much larger volumes of data, which we've talked about again with the Internet of Things, and we're capturing all this data, we're communicating more and more and more. So fibre allows you to do that in a much faster data transfer rate and over greater distances ultimately. So again, coming back to the standardization, we've started to introduce fibre connectors that are available in some of our standard product offerings. We have a 4000 series, we have a 6000 series fibre connector, and we offer these in the classic kind of array of products or the portfolio that you'd expect. So a customer can come to us and they can buy the flex connectors that they need to make a cable assembly. We'll ultimately produce those for them as well. But they can get that bulkhead fitting that obviously mates with it, and they can combat the same challenges they had, but integrating fibre into their offerings, and therefore being able to deal with these much higher and much faster data transfers.
So we've talked about power, we've talked about signal, we've talked about data, and I think there might be a temptation for viewers who aren't necessarily in that classical industrial environment to think that waterproof connectors and harsh environment connectors aren't for us. But one of the interesting things that I've always found when I've looked at Bulgin products is the sheer range of applications in which you might find a Bulgin connector, everything from agriculture to leisure equipment. So what are the markets that you see as important, and what are some of the most interesting that you guys have worked with?
So, yeah, I mean, Bulgin products have been used in many, many different applications over a prolonged period of time, as we've talked about. And really, we see new applications all the time for the products. And it's really to do with the fact that technology is becoming so much more adopted, that as we introduce technology into more and more elements and aspects of our lives, whether it's in a, like you said, leisure or pleasure environment, or the more classic industrial and so on and so forth, we're seeing more and more demand for a product having to have connectivity in a way that it didn't previously. So it's almost the advances in these products that are meaning that they're having challenges they didn't previously have. So some quite interesting examples that we see. I think, like I said, leisure equipment is becoming more and more. So we're having, let's say, about cycling. Cycling is something that is a really common hobby of many people across the world. And now we're having electronics on a push bike. So there was never a need to have a connector that could withstand vibration and dust and dirt ingress and being locked up on the street, perhaps when someone's cycled into town. But now we're introducing batteries and motors onto these sort of devices. So inherently, we're now seeing new industries having requirements for these connectivity solutions that need to deal with these sort of conditions where it just simply wasn't the case before. So I think that's really interesting. And then, of course, you get your kind of industrial settings where mining and oil and gas and marine, and we see some really interesting developments there, particularly in some of these industries that have been around for a long time. Oil and gas is a good example. And a lot of oil and gas devices, particularly downhole tools, were always passive devices that were inherently controlled by the environments they were in. So we're talking about valves that operate against a spring, for example, so on and so forth. But now we're seeing products that are capturing data, they're powered downhole, and therefore, again, much like the example I talk about with cycling, we're seeing products that never used to have a requirement for connectivity and now do. And I think that's really interesting. I think it will continue.
And then there's I suppose there's one more big application that we could talk about, and that's renewable energy. We're seeing windmills, we're seeing solar farms all over the place springing up. And of course, all of those are going to need both power and data connectivity. So I'm guessing Bulgin is going to play a fairly major part in that renewable and sustainable economy.
Yeah, absolutely. And again, that's becoming more and more widely adopted. So we see big wind farms offshore, we see them in the countryside, along with solar and the various different infrastructure that needs to go along with that. But increasingly, we're seeing them adopted into a more domestic setting. So we see people with solar panels on their homes. We see people using these sort of renewables in, again, leisure. So if we talk about, motorhomes increasingly are self-sustaining in their energy consumption. They have solar panels on the roof, they have battery banks, they have inverters that provide for the power consumption needs that the vehicle has and that the individuals have whilst using these vehicles in off-grid type settings. And I think, yes, Bulgin absolutely will continue to provide these solutions for this ever-growing demand.
This is the fascinating thing about where these connectors are being used, in that there is almost no limit to the potential applications in which they're going to be found. And I think we're probably going to summarize here and say that the need for this type of connector is simply going to grow. We've got more and more data-driven applications that go into, whether it's the domestic home, whether it's the agricultural sector. There's the leisure sector that Thomas has just talked about in terms of simple bikes having electronics built into them. So we are going to see a greater need for data and power connectivity in these tough environments. And I think that's one of the key takeaways from this, that we need to provide solutions for these applications, which means that we need to understand more about the environment. So if there's anything that you take away from this video, I think that the key message is make sure that you understand the environment that you're designing for, and then that will enable you to start choosing the products that will perform the best for your particular application. And of course, RS Components is a key supplier for connectors and other components within these harsh environments. And there is tons of information that you can find on RS about the entire Bulgin range. So we've got the tiny little 400, 4000 series, all the way up to the big 900 power connectors. There's even an ATEX version, which is designed specifically for these hazardous environments, these potentially explosive situations. So the Bulgin range within the RS Components offer is huge. There are plenty of bits of information. So please make sure that you visit the RS Components website to find out a little bit more. There'll be more information available on Design Spark to go with this video, and we'll put some links to some of these key products in there. And we can also talk a little bit more about the type of information that you can get from the RS Components website. All that remains for me to say now is to Thomas, thank you so much for sharing all this information about what is a fascinating topic.
No, thank you. It's a pleasure to be here, and yeah, we could definitely talk about connectors for some time. So no, it's been a pleasure, and hopefully we can continue the discussions in the future.